Good morning. It's November 4th, and this is your daily brief in science. Here's everything you need to know. The discussion around water fluoridation in the United States has taken a new turn, with implications for public health and political discourse. The history of water fluoridation began in the 1950s, when federal officials endorsed it as a preventive measure against tooth decay, a move that is now recognized by the CDC as a significant public health achievement. Fluoride is well known for its benefits in strengthening teeth and reducing cavities. However, recent studies have raised concerns about potential links between high fluoride exposure and lower IQ in children. In response to these concerns, U.S. District Judge Edward Chen has ordered the Environmental Protection Agency to address the risks associated with fluoride, citing growing evidence of its potential harm. Adding to the debate, Robert F. Kennedy Jr. announced that Donald Trump would seek to eliminate fluoride from drinking water on his first day in office if elected. This statement, made on November 2, 2024, was shared on social media and linked to Trump's campaign slogan of "Make America Healthy Again." The Trump campaign has not yet commented on Kennedy's remarks. While Trump cannot directly mandate changes to state fluoridation policies, his stance could reignite a long-standing debate over fluoride that has persisted since the 1950s. Health experts are now examining the implications of fluoride exposure, particularly the potential risks, as the debate over its use in drinking water intensifies. High levels of fluoride can lead to dental and skeletal fluorosis, but these conditions typically arise from chronic exposure well beyond safe limits. Some studies have indicated potential risks to infants from high exposure levels, prompting calls for further research. Experts caution that Kennedy's proposal could undermine public health expertise in the U.S., especially if Trump wins the upcoming election. Globally, approximately 435 million people have access to fluoridated water, a practice common in countries such as the U.S., UK, Canada, and Australia. A recent study has raised critical questions about the long-term effectiveness of mRNA COVID-19 vaccines. Conducted by Dr. F. Yoon-Hyung Lee at Emory University and published in Nature Medicine, the research focused on the immune response of 19 adults aged 20 to 65 who had received multiple doses of these vaccines. The findings revealed a significant lack of long-lived plasma cells in the bone marrow, which are essential for sustained antibody production. This deficiency limits the body's long-term protection against COVID-19, indicating that both vaccination and previous infections do not confer lasting immunity. Consequently, this leads to an increased susceptibility to reinfection over time. The study highlights that the mRNA vaccines show a decline in antibody levels within a few months, in contrast to vaccines for other diseases like tetanus, which can provide protection for up to a decade. Participants demonstrated stable immune responses to those other vaccines, emphasizing the limitations of current COVID-19 vaccine technology. Additionally, the researchers pointed out that the structure of the coronavirus spike proteins may hinder the effective development of plasma cells, as B-cell receptors struggle to bind to these proteins. The authors stress the urgent need to enhance the durability of protection provided by mRNA vaccines, as achieving long-lived plasma cells is crucial for future vaccine development. Immunologist Martin Bachmann has suggested that exploring virus-like particles may present a more effective platform for future COVID-19 vaccines compared to the existing mRNA technology, underscoring the need for further research into improved vaccine formulations and delivery methods. A recent study has raised concerns about the impact of cannabis use on adolescent brain development, specifically highlighting the effects of tetrahydrocannabinol, or THC. This multi-level research involved exposing adolescent male mice to THC, revealing significant changes in gene expression related to synapse and dendrite structure, leading to dendritic atrophy. The findings showed that THC exposure resulted in a reduction of dendritic branches in the mice, which aligns with predictions observed in human studies. Notably, the study indicated that THC induces shrinkage of dendritic arborization, a crucial component for neuron communication, potentially impairing overall brain function. Moreover, THC appears to facilitate the removal of synapses through its action on microglia, providing insights into the neurobiological effects of cannabis products. Dr. Paus emphasized that a decrease in dendritic input could hinder learning, social interactions, and adaptability, making adolescents more vulnerable to life challenges. Experts are highlighting the significant implications of these findings for adolescent brain health, particularly regarding decision-making and the heightened risk of psychiatric disorders, such as schizophrenia. In light of these risks, clinicians are encouraged to discuss cannabis use with adolescent patients, especially those with a family history of mental illness. With the rising concentrations of THC in commercial cannabis products and increasing usage among North American youth, understanding THC's impact on brain maturation is essential for public health initiatives. The collaborative study utilized advanced techniques in cellular biology, imaging, and bioinformatics to deepen the understanding of cannabis and its effects on adolescent brain development. Researchers also called for further studies to include female subjects and investigate potential sex differences in cannabis effects. These findings were published in the Journal of Neuroscience, underscoring the urgent need for effective public health strategies to address the implications of cannabis use among adolescents. A groundbreaking study led by Peter Buehler from the Planetary Science Institute reveals that frozen carbon dioxide on Mars played a crucial role in melting significant amounts of water without relying on climatic warming. This research indicates that a thick layer of carbon dioxide ice, resting atop a substantial layer of water ice, acted as an insulator, facilitating the melting of water from the base of the ice cap. Buehler's model provides insights into how the accumulation of carbon dioxide on ice caps led to the formation of subglacial rivers, ultimately creating eskers, gravel ridges formed by ancient river systems beneath glaciers. These eskers have been identified near Mars's south pole, supporting Buehler's findings and suggesting a history of subglacial meltwater, which challenges the previous assumption that global warming was necessary for the presence of liquid water on the planet. As meltwater flowed from beneath the ice sheets, it formed slow-moving streams that eventually created large lakes, such as the Argyre Basin. This indicates a sustained hydrologic cycle on ancient Mars, providing a new explanation for the formation of ancient river valleys without the need for unexplained climatic warming events. The study suggests that around 3.6 billion years ago, Mars had flowing rivers and a lake comparable in size to the Mediterranean Sea, all existing beneath thick ice ceilings. Buehler plans to conduct further tests on this model to confirm its predictions regarding Mars's water cycle and its historical climate, highlighting the minimal atmospheric influence on water flow. Buehler's model emphasizes the interactions between Martian regolith and the southern polar ice cap, suggesting that the carbon dioxide cycle could have persisted for millions of years. This demonstrates a polar-to-equator water cycle that does not require a warmer climate, while also highlighting how Mars's rotational tilt affects the carbon dioxide cycle and its deposition at the poles. Overall, these findings may lead to a significant reevaluation of Mars's ancient hydrology and climatic history. A recent discovery has shed light on a rare pigment disorder in a spotted rough shark, marking a significant first for the species. Led by shark expert Andrej Gajic, the research team identified this case of leucism in a shark caught in a trawler's net off the coast of Vlora, Albania. The spotted rough shark, known scientifically as Oxynotus centrina, measured 64.5 centimeters in length and weighed 2.4 kilograms. Unlike the typical dark gray to brown coloration of its species, this individual displayed a pale hue with white-gray spots, making it a unique specimen. This species is classified as endangered and is listed on the red list of threatened species due to its declining population. Preferring deep waters between 50 and 600 meters, the spotted rough shark is rarely seen by humans, contributing to its status as one of the ocean's most elusive species. Current research in the Mediterranean is also focusing on the last remaining white sharks, indicating a broader effort to study shark populations in the region. Gajic noted that the observed pigment disorder might be genetically linked or influenced by environmental factors, including human-induced stress and temperature changes, which warrant further investigation. Most pigment disorders in marine life are typically genetically driven. However, Gajic emphasized the need to explore additional factors such as hormonal changes and environmental stressors, including increased temperature and inbreeding. The discovery was shared on Instagram by marine biologist and photographer Elias Newman, who highlighted the rarity of encountering this species due to its deep-water habitat. In related news, a tourist in Croatia recently spotted 2 sharks on a beach, underscoring the infrequency of shark encounters in the Adriatic region. Additionally, the spotted dogfish, another small shark species, is also classified as endangered and appears on the red list of threatened species. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.